In the previous video, we modeled all the components needed for the crank slider mechanism with SolidWorks. In this second part of the tutorial, we are going to create the final assembly. So, create an assembly file, and then this is the assembly workspace. Since we have opened all the parts here already, there is this menu here that contains all the parts that have been opened, where we can just click and then drag. If you do not want that, you can close this, and to insert a component, come to insert components to bring back this menu. You can use the browse to go to any folder that contains your files if they are not already opened. Since my files have already been opened, I'm going to just click on them and then add them directly here. The first component I'll add will be the crank disc. Click on it, and when you move your mouse here, click. By default, when you add a component, the first component will be fixed. So right click and then float. So you can click on it and move it. We want to fix the crank disc in such a way that it only rotates about a fixed axis. Now, to fully define or fully constrain a part so that it doesn't move, we need 3 mates. Since we want to move it along just one axis, we are going to add just 2 mates. So the first mate, you come to this mate command. You want to mate the origins, which is very important. So the origin of the assembly workspace and then the origin of the crank disc. You can see the align axis here. Uncheck it, because if you check it, it's going to make it fixed. So uncheck the box and then OK. That is the first mate. The second mate, I want to check the degree of freedom, so you can move it here. We don't want that. So we want to also align the front plane of the assembly workspace. We want it to overlap with the front plane of the crank disc. So now when you click on it, you only move in this direction. So this is what we want for the crank. So OK, and we insert the next component, which will be the connecting link. So mate, and then this face and this face. OK, and then this and this should also coincide. OK. We're going to insert the third one, which will be the collar. The collar, we want to rotate it about the y-axis so that you can enter in this hole, and then use the mate to align this hole and this shaft. Okay. Now rotate and then click on these 2 faces for them to coincide. Then the slider will enter here. So insert component, insert the slider. We want to make the slider vertical, so rotate about the x-axis and insert the slider into this hole. Okay. Now I want to set a distance between these 2 faces. So come down to distance meet this face and this face. The distance should be 50 millimeters. Okay. Now let's try and move the crank and see. This is what we have. Now we make sure the bushing will be at the top here so that it will constrain the slider to move only in a top bottom motion. So insert the bushing. Again, rotate about the x-axis to make it vertical. And then we want to meet the whole of the bushing and then this shaft or this slider. Click on the slider and then this hole. Okay. Now you have to set some distance to fix the bushing at the top. So the distance between the top plane of the assembly workspace and this face of the bushing. I want to set it to 10 millimeters so that it comes downwards. And then the third meat we'll add to the bushing will be that you make sure the right plane of the assembly workspace coincides with the right plane of the bushing so that it will be in the middle here. Okay. Now we check the motion again by rotating the crank, and this is the kind of motion we want for the crank slider mechanism. So this crank slider mechanism is very useful in machines or devices that require reciprocating motion. An example could be a sewing machine. So yeah, this is the final assembly of the crank slider mechanism. That is the end of this part of the tutorial. In the last part, which will be the third part, we'll add the motion steady. So I'll see you in the next one. Save this, rebuild and save the document as the final assembly.